and welcome to Math Molecules. This is a short tutorial to understand Pythagoras theorem and its applications. Pythagoras was a Greek philosopher who found something very interesting about a right-angled triangle. Before we move ahead with the theorem, let us understand a right-angled triangle. Any triangle with one of its angles equal to 90 degrees is called a right-angled triangle. Now there are specific names for these sides of a right angle triangle. The side opposite to that of the 90 degree, the right angle, is called the hypotenuse. It is the longest side in a right angle triangle. So how do you identify which side is the hypotenuse? It is the side which is opposite to the right angle. And the other two sides are called the legs. They are also called as the perpendicular or the base. No matter how your right triangle looks like, the way to find out the hypotenuse is you always have to see the side opposite to that of the right angle or the 90 degrees. So here this is the hypotenuse. In this figure, this side is the hypotenuse and it is also the longest side. So it is easy to identify the hypotenuse, and the other two sides are the legs. So I hope you've understood what a right angle triangle is and what is a hypotenuse and what are legs. Now Pythagoras found out a relationship between the hypotenuse and the other two sides. Let's see how. So this was a right angled triangle. If we produce these sides, for example, if this BC, I am going to produce it as a square. And the side AC, again I produce it as another square. And finally the side AB, I have produced it as another square. So the sides I extended and make a square out of it. What Pythagoras observed was the area of these two squares, the purple and green square, when it was summed up, it was equal to the area of this yellow square. Now, as we already saw, the sides were A here, B here, and this was C. So the area of this square, the purple square area, would be A square. The area of the green square would be B square because all the sides are B here. And since here all the sides are C, the area of this square would be C square. So what Pythagoras found was C square, the area of that big square, is equal to sum of the areas of the other two squares, which were produced by the legs of the right angle triangle. So this was Pythagoras theorem. This is a simulation of Pythagoras theorem. To understand it better, this is an applet created on Geogebra. So the triangle here is ABC is the right triangle, and when I extend the sides AB and I make a square, I get the square 1. BC, when I extend and make a square, I get the square 2. And the side AC, which is the hypotenuse, when I extend it, I get the square 3. Now I am going to play with this triangle and increase or decrease the length of the sides. What we would observe is the area of square 1 plus square 2 will be the area of square 3. Keep watching these numbers and you can see this for yourself. So I'm increasing the side or decreasing it. Any of the sides, if I increase, make the triangle very tiny. In any case, the area of the two squares, when added up, we get the area of the largest square, which is the square made out of the hypotenuse. Thus, the Pythagoras theorem is proved. This is a simple proof of Pythagoras theorem. Area of square 1 is b square here. Area of square 2 is a square, and that of area of square 3 is c square. Therefore, we would get a square plus b square equal to c square. Now let's understand the converse of Pythagoras theorem. If the square of the length of the longest side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. Here the condition given to us is the square of the longest side is equal to sum of the squares of the other two sides. From the condition we arrive at the conclusion that the given triangle is a right angled triangle. For example, in triangle ABC with sides A, B and C, we have a condition c square equal to a square plus b square. Then we say that the given triangle ABC is a right angled triangle. Now let's understand what is a Pythagorean triple. Pythagorean triple is nothing but a combination of three positive integers such that the square of the largest one is equal to the sum of the squares of the other two integers. For example, let's take the example 3, 4 and 5. Let's check if it is a Pythagorean triple or a Pythagorean triplet. So 5 square, the largest one is 25. Now let me add the squares of the other two integers, which is 3 squares plus 4 square, which is 9 plus 16. I get 25. So the square of the largest one is equal to the sum of the squares of the other two integers. Therefore, I can say that 3, 4 and 5 form a Pythagorean triple. If I construct a triangle with sides 3 units, 4 units and 5 units, then I would get a right angled triangle. Let's see few more examples of Pythagorean triplets. 3, 4, 5 is the basic one. If I multiply each of these numbers with 2, I get 6, 8, 10. If you check, 6, 8, 10 is also a Pythagorean triplet. Similarly, if I multiply it with 3, 9, 12, 15 is also a Pythagorean triplet, and multiply with 4, 5 and so on. Any multiples of these basic triples will also be a Pythagorean triplet. Similarly for 5, 12, 13, 7, 24, 25 and so on. So these are few basic Pythagorean triples which you will come across in various problems. Now let's understand few applications of Pythagoras theorem. The first one would be to check if the given triangle is a right angle triangle. We can use the converse of Pythagoras theorem and check if the square of the largest side is equal to the sum of the squares of the other two sides. And then you can confirm if the given triangle is right angled or not. Also, to find the length of the unknown side if two sides are given in a right angled triangle. You can always find the third side. It is also used to find the diagonal of a square or rectangle. We would be covering an example of each of these applications in the next video. I hope this tutorial was helpful in understanding the Pythagoras theorem, the converse of it, as well as what are Pythagorean triples. Thank you so much for watching Math Molecules.